realize is you don't have to do purely one or the other one. In real life, can't you select like 20 out of all the hospitals, but then only take 500 patients from each hospital? Isn't that a mixture of cluster and stratified, right? So in real life, there's going to be those mixtures, but here I'm going to assume that those are the only majors they offer, and then that's stratified. But now you see another reason why I ask you to explain your reasoning, because if you say, I don't know if that's all they have, so I'm just going to have to say random or something, or something, I'd understand where you were coming from if you had a different way of looking at it. Okay. Blah, blah, blah. Okay. Cool. So any questions about sampling procedures? Sorry, I just really want chapter 1 to be done. Definitions are important, but they definitely kind of weigh you down in the early going. And I don't want you to feel like the entire class is going to be definitions. Yeah? Sorry.
13 for on-ramp.
What about wine tasting? In section 1.5? Wine tasting. So the author observed wine tasters at the Connecticut testing facility. A taste test involves 3 different wines, randomly selected from each of 5 different wineries. So there's 5 different wineries. This is one where you could argue 2 different ways. You could say stratified, and I can see that, because you took some from each of the 5.
Or simple.
Or it might be random selection, right? You could call it random because you don't know if that's the only 5 wineries. And they just randomly picked it and just happen to be from 5 wineries. But I would definitely go with stratified on that one. Right? Do you guys see how there could be a little bit of play there? But I would say that's definitely stratified. 5 different wineries, they randomly selected a few from each. So some from each. Cool. Okay. So we're slowly building up our way towards calculator usage. So I think last time I gave you that calculator Bible. Did I? I think okay. Did you get my email about the workshop? Yes. If you're not getting emails from me, come see me after class. I want to make sure I get you, figure out what's going on there. If your email is correct in WebAdvisor, you should be getting emails from me about workshops and whatever. So there's a basic TI graphic calculator workshop. It's going to rerun 5 different times. So if you've never used it before, you might want to go to that, just to get the basics down. It's not going to be stats specific at all, because I'm going to have people from like 110 and pre-calculus and other courses too. But it's just going to be purely on the basics of the TI, graphic calculator. Oh, there's 5 different times. And they're all on the website, on the Math Study Center website. There's a workshop schedule you can click on. Okay. So now chapter 2. So we survived chapter 1, at least so far. Hopefully in your homework you survive it. Chapter 2 is not quite yet where we analyze things too much. It's all about representing what we find. So representing data, representing samples, creating graphs, bar graphs, things called histograms. The very first thing we're going to do is the most basic thing you can do. It's almost like a tally sheet. Guys will play along with me. I think we're going to try, this is where I wanted that data. Has everybody done that survey yet? I noticed the last time I looked there were still about almost 20 people that hadn't done it. So If you haven't done it yet, there's a survey. If you're not getting my emails, you definitely don't know about it. So there's a survey, there's a link on the website, fill it out. So today you're going to help me out by giving me some information. Anybody uncomfortable about telling me their age? Yeah. I like that. Young dude in the back. Yeah, man. It's personal. All right, so you guys are going to help me. You're going to tell me your age, and we're going to analyze that data. We're going to see the distribution of ages in our class, right? So I'm going to throw myself in the mix too. And through doing that, we're going to learn the first 2 sections of Chapter 2, about how they work, what to do. And I'll tell you this right now, when you do your homework, you want to do Section 2.2 and 2.3 at the same time. Because 2.3 refers to the work you did in 2.2. I made sure they're the same sets of data. So don't turn in 2.2 and start to do 2.3 and go, oh, crap. All right? Yes, ma'am?
So the homework that would be due next Monday would be 1.5 and then 2.1, since that's what we're covering today.
We'll see. 2.2, we'll see how far we get. If I finish it, then it'll be due a week from today. Yeah.
All 3 of them?
As far as I finish. Yeah. Whoa. So, here we go. I'm going to start this way and kind of zigzag my way back. So I'll put myself up here first. 38.
48.
48.
22.
22.
40.
Start singing.
40.
40.
41.
41.
20.
20.
38.
38.
22.
22.
18.
18.
20.
20.
24.
24.
42.
22.
30.
30.
25.
25.
19.
19.
23.
23.
20.
20. 18. 19. 27. 27. 22. 21. 24. 27. 27. 20. 21. 22. 18. 19. God, I got a lot of you guys. 23. 17. 19. That's funny, I like that. 17. 17. 18. 21. 19. Hey guys. 22. 19. 27. All right. 27. 21. 21. Oh, sorry. 21. 22. Almost there. 20. 20.
20.
20.
19.
19.
Legal.
Legal. 21. It's different levels of that.
19.
19.
19.
20.
20.
22.
27.
27. All right. Now, what we want to do with this data is we want to try to represent it in a visual form. And the thing is, you're going to start to notice how much flexibility there is in your options and how to represent it. So that's why, of course, you got to be careful. If somebody has a certain thing they want the data to look like, they can kind of try to change those options to make it look a certain way. So what you do is you just go in without any forethought of trying to do that, and just try to do the best you can. Now, I want to first start off with what's the highest and lowest ages you see up there? 48 and 17. So what's the range of ages that we see?
20 or 21.
The range, it goes from 17 up to 40. So how big of a range is that? 31. So it's high minus low. 31. So the ages range over 31, between this and this is 31 apart. So here's what I want to do. I want to make, I eventually want to make what's called a histogram. It sort of looks like a bar graph, but it's called a histogram when it's truly numerical data. So you've all seen bar graphs, and you don't have to draw this, but you put like BMW, and you put Honda, and you look out there and you say, okay, there's this many of those, there's this many of those. We've seen those before, right? And this is 1, 2, 3, 4, 5. Cool? That's a bar graph. And see, this is not numerical data. That's why there's gaps in the middle. This is not a true scale here, is it? It doesn't go 0, BMW, Honda, right? There's no BMW 0.5, right? So when I want to make this representation, I want it to look like this kind of thing here. No gaps. And this will be the ages here. So from this to this age, there's this many people and so forth, right? So we've got to first figure out, how do we determine how wide each of those rectangles is going to be? I don't want it to be 31 wide, because then there'd just be one big-ass rectangle sitting there. There you go. There's the distribution. Thanks for that, really. So how do we determine how wide it's going to be? Well, two things I got to know then. One thing we already know. How much do I have to cover?
31.
31. And then I got to know how many rectangles do I want to use. So physically, if you want to think about it physically, let's say I wanted to cover this with pieces of wood, because I got nothing else going on. And I want to use like 5 pieces of wood. How wide would each piece of wood have to be? How would you do that? Measure this. How far is it? And that's what the range is for us. And then divide it by 5. Wouldn't that be how wide you have to be to cover the whole thing? Physically, that makes sense. Exactly the same damn thing we do over there. To figure out what's called the class width. Each of these is different classes. To figure out the class width, it's the range divided by the number of classes. You always use between 5 and 10. I think the book says 12. You're pretty much never going to use 12. You use less classes for a smaller sample. Smaller samples on the order of 20, 30, 40. Larger samples on the order of hundreds, right? So the range is 31. The number of classes I want between 5 and 10. How many do you think I should use here? 5. I love it. Might as well. If you said 6, that's fine too. Just don't use 10. Right? The bigger the sample is, the more classes you should use. This is a relatively small sample, believe it or not, so I'm going to use fewer. I'm going to use maybe 5. And what is 31 divided by 5? 6.2. I like it. Right? Trick to divide it by 5 is you double it, and that's divided by 10, so you move the decimal back one, so 6.2. You always round this up. Now, why does that make sense? If to cover the damn thing, every rectangle has to be 6.2. If I round down, will it cover it?
No.
So I round up. And I want to make a nice whole number to make it easy for me, so I'm going to round up to 7. That's my class width. That's how wide I want every rectangle to be. How we doing? And again, this is all, what have I already run up against that I have flexibility on? The number of classes I use. The next thing is the number I start at. I have flexibility on both of those counts. Oh crap, I don't want to erase my data. Okay. So has everybody got this here? Okay. So let me keep track of what we got here. All we really need right now is the class width is 7. So the first thing I'm going to do, what section 2.2 is all about, because I'm going to do both 2.2 and 2.3 somehow in 10 minutes. What section 2.2 is all about is called a frequency